Here we want to talk about mixed numbers, rules for mixed numbers, but mainly what do they actually mean. So if I have 2 and 2/3, so without looking at any of the multiply add rules, let's look at what does 2 and 2/3 mean. It means I want 2 whole objects and 2/3 of another one. Let's say I'm baking 2 whole cups and then a 2/3 cup. So I have all of this one, all of this one, and just 2 out of 3 possible pieces on the other one. So 2 1/3 size cups, maybe if I was baking, I'd pour them in there. So if I want to change this to a fraction, then really it's just a shorthand. They found, hey, since I had 2 whole objects, it was easier to count these 2 as, say, I have 2 whole things, and then I have part of another one. But if I wanted to turn it all to fractions, think 2 and 2/3 means 2 plus 2/3. And since 2 is a whole number, I can think of that as 2 over 1. So really I have the same problem. They're different size pieces. This is saying I have one of these 1/3 size pieces and one of these. And here I have 2 whole pieces. If I can cut them up into the same size, so it looks like thirds here, I could just instead call it by how many 1/3 size pieces I have, count them all up. Or let's think if I'm baking, I already used the 1 cup, it's dirty, it's in the sink, I don't want to clean it. Maybe I could just grab the 1/3 cup and use that a bunch of times instead of cleaning the other one. I actually do that quite often. So if I'm talking about how many times do I need to use the 1/3 cup, say to be the same amount as 2 and 2/3. So here I have 1/3, 2/3, 3, 4, 5, 6, 7, 8. Or another way to think about it is, if I'm thinking the whole number part, if I have 2 whole pieces, each one is 3/3. So I have 1, 2, 3, 4, 5, 6. So 2 over 1 is the same as 6 over 3. And notice that fits with our normal rules of multiplying the same thing on the top and bottom. If I want to turn these into 1/3 size pieces, I have to multiply by 3 on the top and bottom. Here I can see 6 1/3 size pieces is the same as 2 wholes. And then I had the 2/3 pieces I already had, so if I count them all up, I can see over here that I have 8 1/3 size pieces is equivalent to 2 and 2/3. All right, so what if we had to go in the other direction? Maybe we have a fraction that's kind of big, so we don't want to have to use a certain cup, 10 or 20 times in a row. Now let's try... Let's do 37/4. So I could take the 1/4 cup and dump it in 37 times. That seems a little excessive. I might get bored and lose count. So instead, let's figure out how many whole cups I could transfer this to, and then just the few that are left over. Well, how many times does 4 go into 37 evenly? So it doesn't go into 37, but it definitely does go into 36. So 36 of these fourths would work out very nicely. I could turn this into a whole number. And so then think, how many do I have left over? So 37/4, I could turn this part into a whole number, and I'd have 1 left over. So as we're writing it down, just make sure we have something equivalent. 36 plus 1 is the same as 37. So we're just splitting it into a part that's going to divide nicely, and whatever's left over. So 36 divided by 4 is 9, and I have the 1/4 left over. And so if I drew it all out, I could see 9 whole pieces plus 1 1/4 cup left over would be the same as using the 1/4 cup 37 times.